Hi students, welcome back. Today we look at Nernst equation and also discuss some questions of electrochemistry. If you haven't subscribed to my channel, please do so we can have more videos on chemistry. The function of the Nernst equation is to determine the electron potential under non-standard conditions. So the formula E equal to E0 minus LT over NF times ln concentration of reduced form powered by X divided by concentration of oxidized form powered by Y. So the E0 here is the standard cell potential, R is the base constant, T is thermodynamic temperature, N is number of mole of electrons involved, F is the Faraday constant. So this is concentration of products reduced form divided by concentration of reactants oxidized form. X is the number of mole of the products, and in the equation Y is the number of mole of reactants in the equations. So if you substitute the value of temperature, gas constant and Faraday constants into the formula, you will get this one. E equal to E0 minus 0.0592 divided by N times log concentration of reduced form divided by concentration of oxidized form. So for example, in this question, calculate the electron potential for the silver half cells in 1.5 mole per dm². Okay, so the reaction involves 1 mole of electrons. The standard cell potential is 0.80 watt. Okay, so you substitute the value inside, you will get the E equal to positive 0.80 minus 0.0592 divided by 1 times log of 1 over 1.5. So the concentration of the solid is not included in the Nernst equation, so you will get 1 here. Okay, now we determine the cell potential under non-standard conditions. So E cell equal to the cell potential under non-standard condition equal to the standard cell potential minus RT over NF times ln Q. So if you substitute the values of T, R and F, you will get E cell equal to E cell naught minus 0.0592 divided by N times log Q. So in other words, it's E equal to E cell naught minus 0.0592 divided by N times log concentration of products divided by concentration of reactants. Okay, what is Q? Q is a reaction quotient, like you learn in ingredient constants. So it's the concentration of products divided by reactants. So for example, if you have these reactions, so the Q is equal to concentration of hydrogen ions, concentration of solid is constant, so don't need to write, so divided by concentration of copper 2 ion. So the hydrogen is gas, so you use pressure of hydrogen gas. So for example, in these equations, we have zinc half cell and copper half cell. So first you calculate the standard cell potential with the reduction electrode minus the oxidation potential, you will get positive 1.10 watt. So the reactions balance equation, okay, you have to write balance equation for the reaction quotient. So we have E equal to positive 1.10 minus 0.0592 divided by 2 times log concentration of the products divided by reactants. So the x and y is 1. So you'll get the final answer. So remember to always write the formula first. 1 mark for formula and substitution. Okay, substitute everything from the equations. And final answer must have sign and the units. Okay, so now we look at factors that affecting cell potential. So we can use the Nernst equation to study the factors affecting the cell potential. So for the temperature factors, so at low temperature, the term of the Nernst equation RT over NF times long Q will decreasing also. So the cell potential will decreasing. Okay, then another factor is the concentration. When concentration of reactants increase, so the term RT over NF times long Q will decrease. Okay, so the cell potential will increase. So when the reactants concentration decreasing, so the opposite, the term RT over NF long Q will increase. So the cell potential will decrease. Now let's look at question 6. So we have several systems. So the standard electron potential of hydrogen is 0 volt at 298 Kelvin. Name an electrolyte with its condition that can be used at the hydrogen half cells under standard conditions. So the answer we have hydrochloric acid, nitric acid, or any strong acid. So the condition must be 1.0 mole per dm cube, standard conditions. Okay. Next question. The electron potential of a hydrogen electrode changes when the hydrogen ion concentration is reduced. Explain how the electron potential changes. Okay, so when concentration hydrogen ion decreases, the position of equilibrium will shift to the left. Electron potential will decreases or become negative. Okay, so for this cell we have platinum electrodes X and Y. So the electrolytes we have Bl2 and bromide ion at the X, and hydrogen ion Bl2 and bromide ion at the Y. So each electrode acts as a cathode. So we have to refer to the potential value here. So for cathode is undergo reduction, so we must look at the potential that is more positive. So we have bromide ion as a electrolyte. So the answer is Y. Construct an equation for the above cells. So first you have to look at the cell again. So we have here bromide ion, so this one Bl2 will undergo oxygen. Bl2 and bromide here oxidations. So bromide ion undergo oxidations. Okay, so you have to balance the electrons. So here have 10, so here have 2 only. So the whole equation here must multiply by 5. Okay, so you have to write the equation for the cell, we have to total up. So this one, bromide ion undergo oxidation. So 5 times 2, we have 10 bromide. 10 bromide plus 2 bromide ions plus 12 hydrogen ions produce, so you can cancel the electron. Okay, 5 bromine plus 1 bromine, so 6 bromine plus 6 water. Okay, so here got 2, so you can divide it by 2. Okay, divided by 2, so you will have, okay, the equation. So that's how the 10 bromide divided by 2, we got 5 bromide plus Br(O3) negative plus that's how 12 hydrogen ion divided by 2, 6 hydrogen ion from 3 Br2, 6 bromine, that's all, 5 plus 1, so plus 3 water. So using the data above to calculate the EMF of the cell potential under standard conditions, so take the formulas, use the formula, E cell equal to cathode's potential minus anode potential. So have to copy the signs, positive 1.52 minus positive 1.09, remember to write the positive. So from final answer, positive 0.43 volts. Okay, which is not true for the cell diagram. So iron is the cathode of the cells. So let's look at the cell again. So the electrode is at the end of the cell. Okay, so for the oxidation is here in this electrode. Okay, then here is the cathode reductions. Okay, so platinum is a cathode, not iron. So we don't have iron solid here. Okay, so A is wrong. So A is wrong. Let's look at the other answers. Okay, current flows from iron half cell to zinc half cell. So this is correct. Okay, so the oxidations produce the electron. So electron falls from zinc half cell to the iron half cells. Okay, so from left to right. So the current will be opposite. Okay, the flow of current is opposite the electrons. So we'll have the current falls from right to left. So from iron half cell to the zinc half cells. Okay. So electric charge moves from positive to negative. Okay. So it's opposite the electron force. Okay, if concentration of iron 3 ion is increased, the EMF also increases. Okay, so this one refers to the Nernst equation. Okay, zinc half cell is less positive than iron half cell, so this is correct. Okay, zinc half cell is oxidation, so more negative. So iron half cell is reduction, so more positive. Thank you very much for watching. Do subscribe and like and share, and press the notification button for the next video. Bye bye.